SpaceX Starship Flight 11 hits key milestones and ends with a stunning splashdown. On a clear Texas morning, the world watched. A giant rocket stood ready. Starship Flight 11. The mission: test new hardware, new maneuvers, new confidence. The most powerful rocket ever built, poised to prove itself. The countdown reached 0. A thunderous roar filled the air. The rocket lifted off, climbing with purpose. Millions held their breath. This flight would push systems to the edge to gather data. It was not just about getting into the sky. It was about everything that happened after. SpaceX wanted to demonstrate control under brutal conditions, to prove this massive vehicle can fly with finesse, and guide itself to a precise splash point in the Indian Ocean. On October 14, 2025, primary objectives were achieved. A step closer to fully reusable super heavy lift. At Starbase, anticipation built as the fully fueled stack waited. Super-chilled oxygen and methane-loaded, frost traced the skin. The deluge system armed to tame acoustic fury. Final checks complete. Go for launch. Around the world, eyes locked on the stream. Sound suppression roared to life. One by one, the booster's engines lit. For heart-stopping seconds, computers checked everything. Release and ascent. 16 million pounds of thrust pushed 120 meters of steel skyward. Through max Q, structures held and guidance stayed true. Onboard cameras delivered breathtaking views. The initial ascent, flawless. The booster burned for minutes, handing off to the next critical phases. Propulsion proved reliable and smooth. Structural integrity, rock solid. A crucial first victory, and only the beginning. Next, separation and the booster's return. Flight 11 trialed a refined booster engine configuration for control and efficiency. The goal: tighter steering with lower losses. Approaching staging, the choreography began. Hot stage separation. Upper engines lit while still attached, exhaust vented through a ring. The maneuver executed cleanly. Starship continued toward the vacuum. The Super Heavy began its own high-stakes sequence. A flip set up the trajectory change. A controlled burn slowed and bent the path toward home waters. Waffle iron fins carved the glide corridor. A landing burn cushioned the descent. Touchdown on water, by design. Upright, then over, objectives complete. Not a failure, a planned finish for the booster test. Systems performed nominally across the board. Each step moves SpaceX closer to full rapid reuse, and to missions beyond Earth. The data haul begins. After hot staging, Starship burned for minutes, then coasted on a suborbital arc. The goal wasn't orbit. It was a long transcontinental flight test. Engines shut down on schedule. At Apogee, hundreds of kilometers up, instruments kept watch. Power, communications, guidance, all nominal. Teams exercised propellant management, vital for future refueling. Texas to the Indian Ocean, a globe-spanning rehearsal. Long-range tracking verified comm links across continents. Near re-entry, Starship rotated to present its heat shield. Velocity neared orbital speeds. The silent coast was over. Dynamic banking sounds complex. The idea is simple. Like a skydiver using arms and legs, Starship uses 4 large flaps. Subtle angle changes create lift and drag to steer. Rolls and banks followed a pre-planned sequence, not a tumble. Banking manages energy, spreads heat, and refines aim to the splash zone. Flight software handled complex aero loads with confidence. Flight 11 proved Starship can glide as a controllable hypersonic vehicle. Steering margin also boosts safety and landing precision. As Starship fell deeper, air turned to glowing plasma. Temperatures soared into the thousands. Black hexagonal tiles absorbed and radiated heat, protecting tanks and structure. Expected radio blackouts came and went. The vehicle kept flying. New robust tiles on hot flap edges performed well. Priceless data streamed on heat, pressure, and flap performance. Through the worst of heating, Starship set up for splashdown. Flaps guided a controlled descent to target. At a few hundred meters, 2 engines fired to flip upright. Throttles modulated to bleed speed. A gentle, powered touch on the ocean. It stayed upright briefly before tipping, all per plan. The objective was to prove the landing maneuver, not recover. A massive win for SpaceX. Return from space, survive re-entry, execute a pinpoint-powered splash. Next steps, bringing vehicles back to the launch tower's giant arms. The splashdown was the perfect conclusion to a near-perfect test. Flight 11 closed the book on Block 2, prototypes that taught SpaceX how to master the atmosphere. They refined hot staging, heat shields, and structures. Now, a final crucial dataset is archived. Focus shifts to version 3, the standardized, more robust fleet. V3 brings advanced engines, tougher tiles, and rapid turnaround systems, with in-space refueling hardware for deep space missions. Starbase is shifting from experimentation to production. For NASA, this is pivotal. Starship is the Artemis human landing system. Seeing controlled re-entry and powered splash boosts confidence. Across industry, the pace quickens. Innovation pressure rises. Expect more investment in reusability and rapid iteration. Flight data validates fast, test-driven development of complex vehicles. Next, analyze terabytes of data, lock V3, and attempt a tower catch, followed by Starship returning to land. A reusable fleet ready to fly again fast. Artemis missions come into sharper focus. Each success brings a city on Mars closer. Science fiction becomes engineering reality, visibly, measurably. Flight 11 passed the final exam for Block 2 and opened the door to the next chapter of space exploration.